Another option you have for solving systems of equations is to graph them. So if you graph two equations, look for where they intersect. So for example, the first one on the left there, we got two equations, x minus y equals 2. That's the one that's going in the positive slope. And then we have x over 2 plus 3y equals 1. You'll see that they intersect at 2, 0. Now we could also have a parabola and a line intersecting at 2 points. You could also have a parabola and a line intersecting at no points. So you can have multiple solutions. You could have, if you have like a linear graph and a cubic graph, you could have 3 solutions. You could have 4 solutions if you're dealing with a quartic. There's a lot of different options. So what we're going to do is we're going to solve this system of equations by graphing. We got y equals the natural log of x, and x plus y equals 1. Now, regardless of what calculator you're using, sometimes if you're using things like Desmos, you can type the second one in. But I'm assuming many of us are going to use TI-84s or the like. So what I'm going to do is I'm going to subtract x from both sides. And so we have y equals negative x plus 1. So that way, if you're using a TI-84 or something comparable like an 83 or a Casio or an HP or whatever, you can just plug it in as is. Now, for simplicity's sake, to show this on the screen, I'm just going to plug this into Desmos, and we're going to take a look at where they intersect. So, on Desmos, we got our two equations. I'm going to do y equals natural log of x. There's one equation. And then the other one is going to be y equals negative x plus 1. And you'll see that they intersect at one point. Now, if you're using Desmos, it's really easy. You just kind of like literally click on where the solution is. And in this case, it's at 1, 0. If you're using a TI-83 or 84, remember you have to go second trace to the calculate menu, then go to the intersect option. Make sure you're using intersect. So we're going to say our coordinates are at 1, 0. That was pretty straightforward. So, graphing. Yay. Now the last part we're going to take a look at is writing a system of equations from information that we're given. We have a shoe company investing $300,000 in equipment to produce a new line of athletic footwear. Each pair of shoes costs $5 to produce and is sold at $60 each. How many pairs of shoes must be sold before the business breaks even? Now this one is, we're probably going to make it more complicated than it really needs to be for now, but this is just kind of getting familiar with writing a system of equations. So that first one, $300,000, we're just going to say that's our initial cost. Now for the other one, we're going to have to come up with a little bit more more complicated of an equation. So each pair of shoe costs $5 to produce. So I'm going to say it's negative 5 times x plus $60. So we got plus 60 times x. And I'm going to say that's equal to r. So we got cost and revenue. So in order for our business to break even, our cost and our revenue have to be equal to each other. So we've got a system of equations, one relating to the cost, one relating to the revenue. What we're going to do is we're going to set those two equal to each other. So we got 300,000, I'm missing a 0, 300,000 equals negative 5x plus 60x equal, or sorry, that's it. Now, of course, that right side we can just simplify to be 55x. So we got 300,000 equals 55x. To solve for x, we're going to divide both sides by 55. And we're going to get, oops, sorry, I'm not in a writing tool right now. We're going to get on the left side 5454.54, and it keeps going forever, equals x. Now, x is our number of shoes, so we're going to say, we're going to round that up. So we're going to say it will take 5,450, let's round it up to 55 pairs of shoes. Can't spell. To break even. Now, since we're rounding up, of course, it's going to be a little more than break even, but it's going to take that many to just get there, to break even. Sorry, I was writing the edge, so it got a little messy.